Good morning. So this is basic electronics engineering course in the digital part. So this is the third lecture. So myself A. Venkat Subbareddy, assistant professor in electronics and communication engineering at G. Reddy Engineering College. So in this session, I will discuss about the different binary arithmetic operations on the binary numbers. So the binary arithmetic is an essential part of all digital computers and all digital systems which uses the binary numbers. So the first we will discuss about binary addition. It is key for binary subtraction, multiplication, division, and there are 4 rules to be followed for the binary addition. Those are, if I have given two numbers, that is A and B, the binary addition it gives sum and carry. So if it is both the numbers are 0 0, then sum is 0 and carry is 0. If it is 0 1, so the sum is 1, carry is 0. If it is 1 plus 2 0, sum is 1, carry is 0. If it is 1 1, then sum is 0 and carry is 2. So that is 1 plus 1 in decimal it gives 2, but 2 is not allowed in binary number, so it is represented it as an 1 0 in binary. So this 1 is 1 0, so the 0 is represented as sum and 1 is called it as an carry. 1 2 is represented in binary as 1 0 because 2 is not allowed in the binary number. So that is represented as 1 0. So 0 consider it as an sum and 1 is considered as a carry. So in the fourth case, binary addition is creating a sum of 1 plus 1, so which is called as an 1 0. So 0 is written in the given column and a carry of 1 to the next column. That is 0 is written under sum and 1 is written as carry. Then you can see one example. So that is the given two binary numbers is 0 0 1 1 0 1 0 and the another is 0 0 0 1 1 0 0. So both these two are 0 and 0, so the sum is 0. Then 1 plus 0, sum is 1. 0 plus 1, sum is 1. Then 1 plus 1, so it gives 1 plus 1, it gives result as 1 0. So 0 is written as sum and carry written over here. Now in this position I have 3, 1 is carry and the remaining 2 are in the given number. So 1 plus 1 plus 0. I got 1 plus 1 plus 0. So again I will get it as an 1 0. So 0 is written over here and carry is written here. Then 1 plus 0 plus 0. So the sum is 1 and the remaining is 0 0. So which is equal to 0. 0 plus 0 is 0. So in decimal, this 11010 is 26 and 1100 is 12. So if add, I will get 38. So we can also verify whether we will get it as an 38. It is 2 power 0, 2 power 1, 2 square, 2 cube. Its position weight is 2 power 4. It is 2 power 5. So 1 into 2 power 5. So 0 into 2 power 4. So 0 into 2 cube, 0 into 2 square, 1 into 2 square, then 1 into 2 power 1 plus 0 into 2 power 0. So 1 into 2 power 5, so 2 power 5 is 32. So it is 0 plus 0 plus 1 into 2 square 4 plus 1 into 2 2 plus 0. So that is 32 plus 4 36 plus 2 38. So which is binary. This is how you can perform binary addition. Then the second arithmetic operation is binary subtraction. So in this case we will get 2, that is difference and borrow. So these two words will be used very frequently for binary subtraction. So if you are subtracting any two binary numbers, so it can generate a difference and borrow. So these are the two words will be used in the binary subtraction. Then again there are 4 rules how to perform binary subtraction. If both the numbers are 0 0, so that is 0 minus 0, so the difference is 0 and borrow is 0. Then the second is 0 1, so that is I have to subtract 0 minus 1, so this is not possible. So 0 minus 1 we cannot perform directly, so we have to borrow from the next position, we have to borrow. So in this case it is in a binary number system, we can borrow only 2 from the immediate left of the position. So we can borrow 2, so we can get 2 minus 1, so the difference is 1. So we have taken borrow from the next to position, so the borrow is become. Whenever we take borrow from the higher position, so this borrow consider it as an 1. Then 1 minus 0, so the difference is 0, difference is 1, borrow is 0. Then 1 minus 1, so the difference 0 and borrow also 0. So this is how you can perform subtraction. So the given number is 11010 and another number is 1100. So you can take 0 minus 0, so the difference is 0. So the 1 minus 0, that is 1 minus 0, so the difference is 1. Then 0 minus 1, that is I have to take a borrow from this position, that is to the immediate left of this where we require borrow. So we have to consider the immediate left of that position and we have to bring back the borrow. So that is I have to bring borrow of 2, that is 2 minus 1, so I will get 2, and in this case difference become 1 and borrow is also 1, so I have to consider this 1. So then again, so now I have taken borrow here from this position and this value become 0. So now I have to perform 0 minus 1, again it is not possible, I have to take again borrow from here to this position. Now it will become 2 minus 1, so 1. Then in this case I have taken borrow already, this value becomes 0, so 0 minus 0 0, then 0 minus 0 0 and 0 minus 0 0. So like this we will take the borrow of 2 and subtract, and from where we have taken borrow, so that bit will become 0. Like this we can perform binary subtraction. So once if we thoroughly know how to perform binary addition and subtraction, then we can easily do other two arithmetic operation, that is multiplication and division easily. So the binary multiplication is similar to the decimal multiplication. It is simpler than decimal multiplication because it has only zeros and ones are involved. There are 4 rules of binary multiplication, that is 0 into 0 0, 0 into 1 0, 1 into 0 0, 1 into 1 1. So this is the another basic example how to multiply. So in the multiplier, if the digit is 0, so we will make one row of the product as all zeros. If it is 1, so I can copy the same as it is in the intermediate product. So in the first position is 0, so I can copy all the bits as 0. In the second also 0, I can copy it as an 0. Then in the third position multiplier is 1, so I can copy the given multiplicand. While writing, I have to shift the position by 1 to the left. Then here it is 1, then again I have to write down. So after this, all these bits are 0, so no need to write down because zeros does not affect on the product. So then after all doing this, I can add all these, then I will get this product, that is 26 multiplied with 12. I will get the product as 312, and 312 is represented in binary by using this representation. Then the another fourth binary arithmetic is binary division. Again, binary division is similar to decimal division. It is called as a long division procedure. So whatever method we follow in the decimal division, so we will also follow the same in the binary division, but the numbers are only zeros and ones, like this. First we have to compare the divisor with the dividend. So in this case the divisor is 110. It is a 3-bit number and the remaining bits are zeros, so no need to consider, only these three you can consider, that is 110. And you have to observe the dividend value, that is 101. So you can observe it is 110 divisor, and the dividend, the first two bits, the first three bits are 101. So in this case the dividend is 101 and the divisor is 110. So the divisor is greater than this dividend, so we have to move to the right of the dividend. So I can consider the first 4 bits, that is 1010. So now I can divide this 1010 with 110. So that is like this. Then after doing this, I have to subtract, that is 0 minus 0 0 0, sorry, 1 minus 1 0. So it is an 0 minus 1, so I have to bring borrow of 2. So 2 minus 1 1. Then I have taken borrow from here, so this 1 become 0, so I can write down it as a 0. Now I can take the next bit, that is 1, so now it is 1001. So the next dividend bit is 1001 and the divisor is 110. So this 1001 is greater than this 110, so I can do subtraction. So each time I have to put quotient as 1. So until I can do the subdivision, either I will get the remainder as 0 or the number which is not divisible by 110 or the division, whichever is there, there I have to stop. This is how you can perform binary division. So all these are the 4 different arithmetic operations on the binary number. Thank you.